Hi again. Let's continue our discussion about earth science by talking about water. And the first thing I want to talk about is the water cycle or the hydrologic cycle. That's the natural circulation of water that begins in the ocean and ends up as rain on the mountains and then makes its way down in streams and rivers back to the ocean. So it cycles from the ocean back again to the ocean. And we can break that down and think about the ocean as a pool of water with salt in it and a bunch of other stuff in there, bacteria and other dissolved salts and things like that. And then, powered by the sun, the water at the surface gets heated up and evaporates, turns into water vapor, a gas. And then as it rises, it cools off, and the water vapor condenses back to liquid water, and the wind blows it over to the mountains, and it cools down even further, and those water droplets collect and form larger droplets until eventually they're heavy enough to fall as precipitation. And then the precipitation strikes the ground. A lot of the rain is absorbed into the ground, makes its way into something called the water table that we'll see in a minute. And then as the ground gets saturated with water, it can't hold anymore, and then the water pools up and begins to flow in a stream and makes its way back to the ocean. Here's another diagram of the hydrologic cycle. And you've got evaporation not only from lakes and the ocean, but you also have some from the trees and plants, all making water vapor that works its way to form clouds and eventually precipitation as snow or rain. And then we also got the flow of water into the ground. And the water can actually flow through the ground back into the ocean, or the water can flow across the surface into the ocean. And you should be aware that the hydrologic cycle is a way to both purify and contaminate the water, right? So if you start in the ocean, there's a bunch of stuff dissolved in the ocean water, but as it evaporates, you have essentially pure water vapor coming up into the air, and then you get nearly pure water dripping back down onto the slopes. And, if you have some impure water in our streams, as it percolates through the ground, some of those particles, some of those molecules found in the water can stick to the soil and be filtered out. So there's processes that purify the water. But with some pollution around, you can also contaminate the water. So if there's some air pollution, as this water vapor makes its way up into the atmosphere and starts forming little droplets, the soot that might be in the air or some chemicals that's found in the air, they can dissolve in those little water droplets of rain and come back down as rain. And if there's any pollutants in the rivers or in the soil, the rainwater can pick those up and the water can be contaminated with those molecules. You may have noticed that after a rainstorm that the air smells really nice and clean. Well, that's partly due to the fact that the rain is actually absorbing a bunch of those impurities in the air, and it is purifying the air. Okay, if you think about all the water on our planet Earth, it turns out that about 98%, that is most of the water, is found in the oceans as salt water. And of the total water on the planet Earth, between 2 and 3% is actually fresh water. And if you take that little slice of the total water in the world that's fresh water, most of it is ice. It's glaciers and at the polar ice caps. And then less than 1% or so of all the water on Earth is found in groundwater, and a smaller percentage is in rivers and lakes. We'll say that water found in lakes and rivers that is on top of the surface of the land, we'll call that surface water. And then water that makes its way into the ground, in or under the ground, well, there's two forms. There's water that just gets absorbed by the soil, that's soil moisture. And if you have enough water accumulate in the ground, they actually can get together and form groundwater. So a little bit more detail here. Soil moisture is a region where the ground is unsaturated, sort of like the sponge down here. It's damp with some water, but you'd have to squeeze this out in order to get any water out. These sponges are not saturated, but if you fill them completely full of water, the sponge will become saturated. And it's the same idea for the soil. If there's some air mixed in with the water in the soil, then it's not saturated. You can displace that air and put in more water. It could take more water. And that means we just have soil moisture. Whereas lower into the ground, gravity kind of pulls down that water and it collects and displaces all of the air, and the water completely fills those pores in the ground. That makes groundwater, and that's a saturated area. The ground is completely saturated with water at that point. And most importantly for us is groundwater is a type of water that we can actually pump out. Because of the air and the soil moisture, you can't actually pump out that water. Okay, so here's another diagram saying the same thing. As water percolates or seeps into the soil, it dampens the soil, and that's your unsaturated zone or soil moisture. And as the water works its way down, dampens the soil, it can accumulate in another area, another region where the ground is saturated, the groundwater. And gravity tries to draw that water down deeper, but then it strikes bedrock or some other impermeable layer of soil or rock, something the water cannot penetrate. There's no pores. And then as this liquid water accumulates in the pores, the top of that is defined to be the water table. You can think of it as the region between the soil moisture and the beginning of the groundwater, or the height of the groundwater. And then this groundwater can flow if it's angled and it moves downhill, and that constitutes an aquifer, a region with underground water that's flowing. A little bit more detail. We got rain coming down here, forming soil moisture. Some of the pores are taken up by water, but other pores have air in it. Work its way down to make groundwater that flows, an aquifer. And the groundwater can be replenished by a stream. The water can actually go into the riverbed, be absorbed by the soil, and contribute to the aquifer, the groundwater. Here we got a tree absorbing some of the water from the ground, drawing that up. And then later down the aquifer, the water can come back up and actually fill another riverbed. And the water can come up and flow downstream and make its way to the ocean. The groundwater can also just continue underneath the surface of the land and make its way to the ocean that way. And then interestingly, the salt water can actually work its way back into the aquifer. So if you're going to drill a well and tap this groundwater and get some drinking water out, you don't want to sink your well too close to the ocean, because especially in times of drought, when the groundwater is lower, the ocean water can actually come in, and you'll be drawing salt water out of your well. If you're curious as to where the water table is in your area where you're living, what you can do is just walk around till you find a pond or a lake or a river. And it turns out that the height of the river or lake is nearly the same as the water table. And what happens in the summertime is as the lake dries up through evaporation, it goes down while the water table spills over and refills the lake. But as it fills up the lake, the water table goes down. And as the lake continues to evaporate, the water table will keep filling it up until the water table slips below the level of the lake, and the lake will go dry. And then we need to refill the water table by getting more rain and snow, melted snow, and they can refill the water table and refill the lake. And this explains why wells go dry. So if we sink a well, here's a wishing well, water well, in the winter time or in the springtime when the snow's melting, there's a lot of water seeping into the soil, filling up the groundwater, filling up the aquifer. And so this well has a lot of water in it. But over the course of the summer, as evaporation happens, the water is used up. It feeds, streams down, rivers and streams further downhill. The water table will go down, and the well is running close to going dry. Now, in areas where there's a lot of water in the water table can actually rise up and be above the surface of the land. And that forms marshes and swamps. Okay, a little bit more about aquifers, right? Aquifer is just a region of underground water that's flowing. You can actually form confined aquifers when there's a segment of rock or impermeable soil above the aquifer. And what does that do? Well, as water fills the aquifer, it wants to spread out. And it can't spread out over here because there's rock above it, and so it keeps moving downward under the pressure of additional water. And now this water is under pressure. Just by gravity, just stacking up the water behind it, forms more weight. And if there's a crack or a well or a spring in this bedrock that's confined the aquifer, the water will flow upward under the pressure of the aquifer. And you get a spring. You can also tap into it with a well, and these natural springs, natural wells, are called artesian springs and artesian wells. Here's another diagram over here. This one's a little bit more clear. As the water table fills up, it wants to level out this way, but it can't because of the confinement of this bedrock or whatever it is that's blocking the water. It gets pressurized, finds a weak spot, and flows upward, forming a spring. And these weak spots often happen at faults. And so geologists out looking for, sites for new earthquakes, new faults, a telltale sign of a fault is the presence of a spring. Here's a couple pictures of springs. We got spring water coming up here and over here. Okay, last topic. Let's talk about river deltas. So in our hydrologic cycle, as the water is evaporated, makes its way over to form rain, comes down, starts filling up these rivers and streams. Well, as the river flows, it can eat away or erode the riverbank. And the faster the water flows and the more turbulent the flow, the more soil and rocks it can pick up in its path. And all this sediment will be carried downstream with the river. Now, as the river enters an ocean, well, the ocean is relatively still compared to the speed of the flowing river. And so as the river approaches the ocean, the water that's present there is going to slow it down. And as the river water slows down, it can't hold all that sediment anymore. And so as it just begins to slow down a little bit, well, the heaviest items, the biggest pebbles, the biggest rocks are going to fall out and settle out at the bottom of the river. And then as the river slows down even further, then you get smaller pieces that'll settle out. And then finally, when the river water enters the ocean and slows down almost completely, then you get the tiniest particles, the little bits of sand and sediment settling out. And as this material, the sediment precipitates out, settles out of the river, you get a fan-shaped deposit called a delta. So here's the Mississippi River Delta found in New Orleans, Louisiana. And this is a satellite image, and you can actually see the flow of all this sediment flowing out of the rivers. And to get a feel for how far away this picture is taken, I'm going to reduce this picture and show a map of New Orleans. So here's New Orleans here, and you can see that there's this large body of water followed by a smaller one. Over here, that's right here. Here's a small body of water and the larger one. So New Orleans is somewhere right around here. And you can see that all this material that's making up new land is formed by this sediment that's being precipitated out in the river delta. And as the sediment precipitates out, it'll clog up a particular branch of the delta. And as it clogs up, the water will flow back and start to overflow the banks of the river and carve out a new path, a new distributary, it's called. And so that's when you get all these little fingers of rivers and streams coming out of a delta. And close to the home, we got the Sacramento-San Joaquin River Delta. Sacramento River's coming down this way, and the San Joaquin's coming up this way. And as the river slows down, as it makes its way to this large body of water, ultimately the Pacific Ocean, the river streams are slowing down, starting to deposit their sediments. That backs up the water, and it finds new paths, new little streams, and you have this network of streams that make up a river delta here in California. And so on this map, where I teach is Los Medanos College. I'm at the Pittsburgh campus. I don't know, somewhere around here, just a little bit west of Antioch. And then the Brentwood campus is somewhere in here. Okay, that's all for now. I'll see you in class.